Hey Bulldogs, Chris Bryant here with today's Network Plus N10-007 video practice exam and a discussion of the correct answer, and the general topic is security fundamentals. Now let's go ahead and get right to that question, then I'll show you the percentages for each answer that I got when I put this out on Facebook and Twitter and LinkedIn. What attack type consists of TCP handshakes that are initiated but never completed? Is that A, a reflective DOS attack, B, a DDoS attack, C, a Syn Flood attack, or D, ICMP attack? And with that in mind, let's take a look at those percentages. And the smart money is on Syn Flood attack at 83.6%. DDoS attack came in second at 10.4, ICMP at 4.5, and reflective DOS attack at 1.5. Occasionally the long shots come in around here, maybe not the fourth long shot, but the second one. But today the smart money is absolutely correct. This is describing a Syn Flood attack. And let's take a look here at why a Syn Flood attack causes the trouble that it does. This is good stuff to know. And it's either you can call it a Syn attack, you can call it Syn spoofing, but it's a kind of denial of service attack. The point of this particular kind of network attack is not to say, get past the defenses and capture information that the attacker should not be able to access. What they're actually doing is stopping us, the legitimate users, from accessing network resources. Now, first I want to take a look at what a completed TCP handshake looks like. And you got your original Syn, no pun intended. That's the first shake of the three-way handshake, is the Syn with a Syn bit set going into our server, or host B, however that's working. Then the recipient of that Syn is going to send back a Syn ACK. And then finally, the third step, done and done, the host acknowledges the Syn ACK. So you have two Syns and two acknowledgments in there. And Syn, Syn ACK, you're done. That's your TCP three-way handshake. Now, how can something this simple be used against us? Here's how. You could have a malicious host sending multiple Syn requests, or you can have a bank of malicious hosts sending multiple Syn requests. And what they're doing is hammering that device, that server in this case, with Syn requests. And you might look at that and think, well, what's the big deal? I mean, the job of the server is to answer these with Syn ACKs. Well, that's exactly what that server is going to do. But the problem then is that the malicious host or hosts are just not going to answer. They're not going to send an ACK back in. That's not going to happen. So what happens is you end up with a server that's just sitting there basically saying, what the heck's going on? You've got all of these half completed or two-thirds completed TCP handshakes, and as more and more of those add up, as the malicious host or hosts continue to hammer the server with Syn requests, and the server keeps kicking out Syn ACKs, well, sooner or later it's not going to have any room to handle a legitimate request from someone like you or I. So that's what a Syn Flood attack is all about. It is, again, trying to prevent legitimate users from accessing the network rather than capturing information. We're going to talk about those kind of network attacks later on. And we'll definitely be doing here in May 2020. I've got new flashcard exams coming for you, along with Network Plus practice exams with multiple questions, not just one, for when you have a few more minutes to study. So please do subscribe while you're out here. And thank you so much for watching today. I'm Chris Bryant, and thanks for making my work part of your success story.